Welcome to Dr. Kate's video on titration curves and derivative plots for the Analytical Chem 1 lab. So I have here a typical output from one of our auto titrators, and I'd like to thank Alexandra for supplying me with this file so I could use real data for doing this video. So we want to do a derivative plot and a titration curve from this output, which is the sodium hydroxide hydrochloric acid titration. So titration curve has pH on the y-axis and volume on the x-axis. So that's our first two columns here in our data. So we're going to highlight from there to the bottom of that column. So that's going to be shift and then end and down arrow. That gives us the entire column. I'm going to scroll back to the top so that the graph will appear at the top. Then I'm going to insert a scatter plot. So there's our titration curve. It is not a complete titration curve. As you can see, it doesn't have the tail end here. The auto titrators stop when they reach the equivalence point, but at least we have the part that we need to determine the concentration of the species. I'm just going to take off the grid lines because we don't need them. So now we want to do the derivative plots, both the first and second derivative. So we have to calculate those. So I'm going to start here. I'm going to put the first derivative in this column, and then the second derivative in the next column. And for the first derivative, we want to start one square down because we're going to be doing the slope. We're going to do delta y over delta x, so we need to subtract. So I'm going to start, as with all formulas in Excel, we start with an equal sign, open a bracket, delta y, so that would be our pHs, so that pH minus this pH, and close the bracket, and then divide by, open another bracket, this volume minus this volume, and close the bracket. I want to make sure that my numbers are the same, so 20 and 19, 20 and 19, and we're good. So that's our first slope, and then I'm just going to copy that down the rest of the column. So I want to highlight the square and then get that little plus sign in the bottom right corner and double click, and it goes all the way to the bottom. So if we scroll down, you can see it goes right to the end of that column. Nice little trick, saves you having to scroll down to copy it. It's really nice when your column is more than one screen long. So for the second derivative, we're going to do the same thing, but our delta y is now our first derivative. So again, equals, oh, sorry, we have to start down one more square, equals, open a bracket, this one minus this one, close the bracket, divided by, open the bracket, this one minus this one, close the bracket. And again, I'm going to double check those numbers. So say I'd managed to offset this one accidentally. Maybe I went here instead. You can see I can just drag these colored squares to where I need them to be. So that's pretty easy. So 21 and 20, 21 and 20, we're good. And then copy it down the rest of the column. Okay, so now we want to add both of them to the graph. So coming up here, or on our graph, we go to our graph tools, and we want to select data. So we're going to add a new series. The series name is going to be first derivative. Our x values are our volumes. So same as for the other ones. Let's get to the bottom. Our y values are our first derivative values. Okay, and that one's done. Then we can do the second derivative. So again, scroll to the top, get our name, and then our x's are here, and our y's are here. And okay, and let's have a look at our graph now. So now we have three plots on our graph, as we can see in the legend. It's going to make it a little bit bigger, so it'll be easier for you to see. So if we look at this scale, we're going from 1500 to minus 1500, which has taken our titration curve and squished it down to what is essentially a flat line. We can't see much on the first derivative either, and that's because of the scale of the second derivative. So what we're going to do is we're going to put the second derivative on the secondary y-axis. So select that line, which is the green one. So I just clicked on it, and then I'm going to right-click on it and get Format Data Series and switch it over to the secondary y-axis. So now the green line is plotted against the right-hand axis, and the blue and the red line are plotted against the left-hand axis. So already we can see now we actually do have a titration curve, and we can see the first derivative plot a bit better as well. So now to make this a little bit easier to read and understand, I'd like to make the two axes symmetric so that the 0 is in the same place on both sides. So here it's in the middle because this goes from plus 1500 to minus 1500 on the right hand side, and on the left hand side it goes from plus 15 to minus 30. Not so good. So we can easily format this axis to have it only go to minus 15. We'll lose a couple of points on our first derivative, but I don't think we'll really lose much understanding of what's going on, because we'll have the line showing where those points would be if you kept following it. So I'm just going to change this axis. So again, select the axis, right click on it. That works for many things in Excel if you want to format them, and I want the minimum to be minus 15. Okay, so now if we look at this, we can see all the information we need. So we can see where the what volume the maxima, minima, or where the derivatives cross 0, and we can see the shape of our titration curve. We can see how many equivalence points there are. The next thing that I would do with this is I would format the two derivative plots so as to not show the points, just to show the line. This will make the graph look much better. The lines won't be so chunky, and we don't really need to see the individual points on the derivative plots because we've got all the individual points on our titration curve, which clearly indicates how many points we recorded. So to do that, again, right-click, so select and right-click, format data series, go to marker options and say we want none. We don't want a marker. So that was the first derivative, and I'll do the second derivative, do the same thing, marker options, none. All right, the graph is starting to look a lot better. I think I'll leave the points here because we do want to indicate how many measurements we made for our titration curve. So we're largely done now. It needs a title, obviously. It needs the axes labeled. So both the x-axis and the two y-axes need to be labeled. Within those titles and labels, you need to indicate what type of curve it is. You need to indicate what you are analyzing and how you are analyzing it. So having pH as a measurement on the primary y-axis indicates we're measuring pH, so that gives our measurement. For the type of curve, it's a titration curve, so that should be in the title. Titration curve, and then of what? In this case, it's of sodium hydroxide with hydrochloric acid. So you want to include their volumes or concentrations that you have available that you knew when you started the titration. The concentration of the titrant may appear in the title or may appear in the x-axis label, one or both, but as long as it's somewhere on the graph. You do run into a little bit of issue with this y-axis on the left, the primary y-axis, because it actually is two different things being plotted there, and they have different units. So pH has no units, but the first derivative does have units. So you could indicate clearly on the axis label the two different possibilities, or you could put the units for the derivatives in the legend. So a couple of different options there. You could, and then you could label the secondary y-axis as being second derivative or second derivative and include the units. So add some titles, make and label the axes, and then the only other thing I might consider is the lines are still a bit chunky. These are the default settings in Excel, so I might make these lines a little bit thinner. I think it will look a little bit better, especially since everything's overlapping, and I might reduce the size on these diamonds that are being used for the titration curve line, again, because it looks a little chunky and there's so many of them, so it might look better if they were a little bit smaller. All of that would be under formatting the data series again. So that's all you need to do. You'll need to do it for all of your titration curves you did on the auto titrator, but it'll be exactly the same process each time. Hope this helped. Thanks.